Welcome to today's lesson on the classification of matter. Today we're going to talk about the differences between pure substances like elements and compounds and mixtures, and how can we tell the difference between them? How do we know when one's created or when the other one's created or not, I guess as the case is. So first thing, just to review some basic vocab here, you need to know what elements, compounds, and mixtures are sort of by definition. So remember, an element is a particular type of an atom, and there's a big periodic table of elements like hydrogen, copper, nitrogen, gold, aluminum. Those are all different elements because they're made of different types of atoms. And then we can talk about compounds. Compounds, when we start to mix those things together, mix isn't the right word, combine those things together into more interesting stuff. So we can have something like salt, sodium chloride, which is an atom of sodium and an atom of chlorine bonded together. And so that's the idea about what a compound is. So if we were just talking about, say, water, for example, and we had two different elements. We've got hydrogen and oxygen. And a lot of people think, well, to make water, all I really need to do then is just to combine hydrogen gas, hydrogen atoms, and oxygen gas, oxygen atoms. So if we just put those in a container and mix them together, we'll make water, right? Unfortunately, no. What we really do if we just spray these two things into a container is we just make a mixture. We've got hydrogen gas and oxygen gas mixed together, but we haven't really done anything yet. So when we take a look at, say, a molecular diagram of this, or a molecular level diagram of it, the one I'm showing you on the screen right there, this zone right in here, is we've got the little hydrogen atoms, or molecules, I guess, because there's two hydrogens bonded together. And then we've got the bigger red oxygen atoms kind of all in there, but they haven't really combined yet, and that's the key point there, is that there's no bonding. So if we don't have bonding, if we just have them thrown together in the same container, that's what we call a mixture. And mixtures are characterized by no bonding, and typically mixtures are a lot easier to separate the components. I could pull the hydrogen out and leave the oxygen behind relatively easily. So how do we actually make water then? If we want to really make a compound, we have to form new molecules. And again, a molecule is a group of atoms that's bonded together. So compounds are made out of molecules. And in order to do this, this is a little bit more difficult because we actually have to take our hydrogen molecules, or hydrogen atoms over here on the left, which are little H2s, and then we have to take our oxygens. We have to do some breaking and rearranging to this. We have to take apart the old molecules, or the old gas molecules that are there, before we can recombine the new ones. And this takes energy. So in order for us to do this, we would have to put something in there, like if we did it with a candle. If we had a hydrogen filled balloon and we popped it with a candle, then all of a sudden we would actually make steam. A little bit of water vapor would come out as those hydrogen molecules were combined with the oxygen molecules to make new molecules known as water. And again, sometimes you have to put energy in to make this happen. Sometimes energy comes out too, and a new combination can make heat and actually get hot to your hand. This can be a good thing and a bad thing. The picture of the Hindenburg there, if you remember your history lesson at all, they used to make these giant flying dirigibles, and they would fill them with hydrogen. Hydrogen gas is great because it floats. You can make these lovely airships and they fly around. The problem is that you add a little bit of a tiny spark to it, just a little bit of energy. That mixture between the hydrogen and the oxygen in the air isn't just a mixture anymore. That spark creates just enough heat to actually create all of this steam, basically, was what they made there. And it actually is very, very flammable as a result. It releases a lot of energy, too, as the oxygen starts to burn, the hydrogen starts to burn. Definitely an unpleasant experience. So comparing these two, how do I know if it's a mixture? How do I know if it's a compound? So if I put two things together and no new molecules are created, original atoms or molecules are there, they're still there, that's a mixture. Same thing, there's not going to be any change in chemical properties because we haven't made anything new. It's still the exact same stuff, it's just kind of stirred up. Physical properties may change, so it may look a little bit different when we're done, but in general there's no new stuff there, it just may be hiding. So for example, we dissolve salt in water is a good example of a mixture where it looks different, it doesn't look like salt anymore. To make a compound, we have to create some new molecules, which means we need new bonds. Some sort of an energy change. Either energy has to be put in or energy has to come out of that process. And a lot of times that feels like a change in heat, or maybe there's fire. And in both cases, or in the case of a compound anyway, we're going to get not only new physical properties, but we will definitely get new chemical properties. Something new is the result of the formation of a compound. There's nothing new created in a mixture. They're just stirred up. So why do we even care about mixtures if really no chemistry is happening? Well, it turns out mixtures are actually really important to us as living creatures. Our world is full of mixtures. So our lovely lake, the water, the air, the soil around it is all mixtures. And a lot of our actual life chemistry occurs in those sorts of things. The water itself in our lake, as pure as it is, isn't truly just water molecules. There's other things that are dissolved in there. Same thing with the air. It's a mixture of different kinds of gases that we breathe. Mixtures are important for us in terms of things like alloys, if you've heard of those. Plastics are a type of mixture as well as chemical reactions too. But there's a lot of compounds that we use in our daily life that are actually created from mixtures to begin with. And a lot of our food and drink is actually mixtures, so, deliciousness. So in order to go a little bit further, we need to talk about some different kinds of mixtures, the way we can kind of take a look at them. There's two big words here on the screen. These are both vocabulary words that you do need to know and be able to use. The first term is homogeneous, and the second term is heterogeneous. These are both combinations of Latin words. I'll talk about the homogeneous more on the next slide. But you know the phrases homo and hetero before. You probably heard those in different things. Homo means same or same throughout, and hetero means different or composed of different things. So I'm going to talk about heterogeneous mixtures here on this screen. Heterogeneous mixtures are kind of what you normally think of as a mixture, like the picture of sand, or if you've seen lemon pepper or salt and pepper or something like that. It's just regular stuff stirred together. And heterogeneous mixtures a lot of times have separate visible particles. So they're pretty easy to see. Not always in terms of what's heterogeneous, because say for example, the oil and water over there on the left side of the screen, that's a heterogeneous mixture. You've got two different phases or two different kinds of materials there. You can see the oil, you can see the water. They're definitely not separate, or they're not mixed up really well. The bottom one, soda. You actually have two separate phases there. You've got the liquid part of the soda, and then the gas part, the bubbles. They're actually mixed into the liquid part. And if you want to talk about those clouds in the air, you've got a similar sort of a thing where you've got the air is one part of that mixture, and then either the little water droplets or even ice crystals that are up in the sky that form those clouds. That makes that a mixture, a heterogeneous mixture. Two different things are present, either with separate particles like the sand, or with separate phases like the gas or the soda. Okay, homogeneous mixtures for us in chemistry class is actually going to be a lot more important to us. And they're kind of tricky because the big kind of homogeneous mixture that we've got, a lot of times they don't look like mixtures at all. And the big one that we talk about a lot in chemistry is a solution. And I'm not talking about the solution to your math problem, but the solution where one thing is dissolved in something else. So salt dissolved in water is a solution, and that's a homogeneous mixture. So what's important about this is that after it's been mixed up, it's now the same phase throughout. It's the salt has been now dissolved in the water. It's not quite in liquid form, but its little particles are all the way separated from each other. You don't have little chunks of salt still in there. This is truly mixed down at the molecular level. You don't even see those different particles. You can't really pick them out with a really tiny pair of tweezers. So they can be a little bit bizarre. And again, most of our solutions, I'll go into more detail here in a second, most solutions are liquid form, like we can see at the bottom one, but there is a solid version of a solution called an alloy that you may have heard of. And that picture in the top center has a couple of alloys and a couple of elements. So aluminum and copper are elements, but the other things that are on there are actually solutions of one metal dissolved in another, like brass and bronze. Steel, or especially stainless steel, is iron and some other things mixed into it, as opposed to just regular cast iron, which is kind of in that top right. So those are some differences between alloys, or solutions, and just their metals that make them up. A couple key terms down here at the bottom, which is solute and solvent, making a solution. A solute dissolves in a solvent, and the resulting mixture is a solution. We'll talk about that some more as we get into class. So why do we call this a mixture? Why don't we just call it a liquid? Because it kind of looks like a pure substance. It looks like just a glass of water or something else. And the key idea here is that a pure substance, like an element or a compound, and that's a key idea, there's only one kind of atom or one kind of molecule. So an element is only that one type of atom. If it's a compound, it's just that type of molecule. So pure H2O would be an example of a pure substance. As soon as we start having more than one type of molecule present, like salt water, now it's a mixture. And you can see in this picture here, they use two different colors to represent the two different types of molecules that are present. And at first, that picture on the left, that would still be a heterogeneous mixture where the solute hasn't dissolved yet. But you can see as that solute finally goes into solution, by the time you move over to that picture on the right, they're thoroughly intermingled. Literally at the molecular level, it's water, salt, water, salt, water, salt. They're right next to one another. And that's no new bonding. It's still a mixture. We're not making some new kind of a particle. We're just really thoroughly stirring them up so that you can no longer really see the separation between them. Again, remember, a solute dissolves in a solvent to make a solution. Okay, so a couple different kinds of solutions, not just liquids, but there are other ways we can do it. We can have solutions that are solids, solutions that are liquids, and solutions that are gases. I mentioned the liquid one before, but the solute, the stuff that we're dissolving in there, can come in a different variety of different forms. So you can dissolve a gas in a liquid, like carbonated soda, before you let the bubbles out. You could have solids dissolve in there like salt. You could have liquids dissolved in another liquid, like honey dissolving in tea is actually a liquid solution. You can have gas solutions as long as you have one thing mixed into another. So the air that we breathe is a mixture of two different gases, mostly nitrogen, 80%, and about 20% oxygen, and a little bit of other stuff that's up in there as well. So in that case, the nitrogen is actually the solvent, and the oxygen is actually the solute. It's kind of a weird way to use those terms. But that would be a gas solution. Solid solutions, like I mentioned on the previous one, alloys are a really good example of a solid solution. Usually they're created as liquids. We melt the metals first, mix them all together, and then kind of freeze them or let them cool down to a solid state. But again, you've got several different types of atoms that are present that are really thoroughly intermixed at the molecular level. This is a nice overview in terms of kind of these terms that we've been throwing around in this video. So everything is made of matter, right? Can't trust an atom because it makes up everything. And everything is made up of atoms. So that's matter for us. And matter can be split into two main categories. On the left, we have the pure substances that are made up of one and only one kind of thing. So the purest of the purest elements, one and only one kind of atom is present in an element. Compounds are also pure substances because they're made of only one type of molecule. Yes, there's more than one element present. There's only one kind of molecule. That special case of bonding them together gives them a little different status. Over on the right, we have our two kinds of mixtures, homogeneous mixtures and heterogeneous mixtures. So heterogeneous mixtures are your kind of regular mixtures, two different phases, two different states. They're together, but they're not thoroughly together. And then you've got homogeneous mixtures, which is more like our solutions that we use all the time, where they're thoroughly mixed up at the molecular level, atom, 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 and really combined that way. So there you have it, classification of matter into our different kinds of substances. So here you should be able to do at the end of today's little mini lecture, you should be able to tell me the similarities and differences between a compound and a mixture. You should be able to tell me the difference between homogeneous and heterogeneous mixtures. And I mean, not only give me a definition, but identify examples if I give you a list of those. But what are the key characteristics? You should be able to identify how a solution is made in terms of what's a solute and what's a solvent. The word solute really throws people off a lot of times. That's the stuff that's present in lesser quantity that dissolves in the solvent. So be careful with that. And then if we have a list of things, you should be able to take a list of topics, or a list of items, I guess, and say, oh, that one's an element, that one's a compound, that would be this kind of mixture, that kind of mixture. So if I put sand and air and soil and salt water or tap water, you should be able to try to kind of identify what sort of materials there are. So there you go. I hope that cleared up some things for you. I'll see you in the next one.